Yeah, thank you.
Okay, it's lunchtime. I heard lots of well drillers always have. Oh yeah, we have well diggers have good stories to tell. So this is one that's happened to us in the northern part of British Columbia. We were on a project. We were doing soil sampling for directional drill. They were going to put about I believe about a 12-inch pipeline underneath this Musqueam River. This was out of Fort Nelson. Springtime, just coming into breakup, and this is one of the things that happened. So I'll give you a little history of this well. This well, we drilled it down to, we cased, drilled and cased to, we got the casing down to 145 feet at one time. Then a lot of action happened, and we finished off the casing. We pulled it back into the clay formation, and then proceeded to do a cementing program to put this thing under control. This area historically, in the drilling I've done around there, we know that there's methane gas around there, but not quite what we expected. But this is kind of how all this transpired here anyway, and we'll try it. When we took this first photo after computer operator.
No, I'm not. Hold on, guys. A little loud. Probably not as loud as.
Hello. Hello.
Oh, we're just getting here ready now.
Okay, anyway, this little bubbles there are real nice stuff of methane gas coming out of there. And I'm telling you here, we decided to fill this hole full of cement. And not knowing the pressures that we'd already encountered, like I said, we had drilled to 125 to 140 feet, we found dry gravel. Little did we know at the time that this was full of methane gas. So we decided, well, we'll fill this hole full of cement, and pull the casing back into place to cement this hole off, and stop this gas. So we pulled this the casing back, but all of a sudden we had a lot of water. So we to cut underwater, we got this pipe cutter. It's built by I think it's Reed Tool Company. But as you can see, under flowing conditions and that, this pipe cutter, and it's adjustable 6-inch, 8-inch, or whatever, you can manually cut pipe at any time you want to cut it. And you don't have to worry about an oxyacetylene torch system. So, it's not showing very good for you, but we're cutting it there, and you can see how we're finishing the cut, and the water just started to come, and everybody says, well, I don't want to get wet, so let's get out of here, you know. But it does the job very, very well. To us, it's a valuable piece of equipment that we keep with on the rig or in the service shop at all times to cover everything that we need to be able to do so. And as you can see, the LED doesn't feel very good. It's 20.9, so the methane gas was around in that general area. And there's another reason for not using the torches. Okay, so this is why we use this for sure. Now here, as you can see, we just pulled it in there. We had the casing cut and we pulled it off. So that's how high the water and gas is going up the derrick of the rig at that time. So, and there's another thing you should never do. Never set your drill rig in the lowest part of the valley. You know, but the engineer wanted it there, so that's where you gotta go to work. Well, this is after a few hours, and you see it we'll call it calm down, and so the water level is down. And if you notice all the white laying in the clear water there, that's still all methane gas sitting in that, bubbling into that water. Coming out of the well. Here's another shot, just basically of the same stuff. And as you can see, there it goes. And you can all the white of the gas in the water, and the water, luckily enough, has taken off that way, but still it was about probably 6-8 inches deep on location. So so you know we you don't want to stand in that much water. So we got we used our trailer we had with the grout pump on it and everything like that to kind of back up and became our new working platform as well as a rig platform. Now here we have built a flow diverter, and we're just installing it on in the well, and that. This flow diverter, next slide will show it, but it consists of K-packers, some fittings, a key, some valves that, well, like enough for in an oil and gas area, some of this large stuff fits around, and that, but K-packer fits pretty tight in casing and does a very fine job. And so we're using, in case we had to use a top drive to push this thing down into position. You can see there's enough water coming out there being diverted, and you can see how it surges a bunch every once in a while. The gas will build up in the system and it's coming out at that time. Yeah, well, you see how drill helpers are sometimes. Okay, this is the top secret valve here. Right. This is what this consists of. As you can see, the two K-packers, and then the 6-inch T, and then we flange down to a 4-inch valve, and left a fitting on top to install a pressure gauge. And the plan was to push this down in position, and we're utilizing the packers to seal and get the flow coming up so that we could weld this thing on permanently. So this is basically how it looks installed in the hole. There, sliding it down in the hole, and the very top, then we welded. My son Kurt, we were surprised. This packer held so good that he was able to weld that fitting right on there. There was no water leaking at all. It was very surprising to us how well this happened to work. And when you're in the middle of nowhere, sometimes things happen that you get lucky. So that's kind of how it's supposed to look inside there. The packer, two packers inside the weld, and weld it to the top of it. So there we're using the top drive there to push that down in position, and you see, as you can see, it's just there's no flows around in that weld area or anything like that. Everything is working hunky-dory, really. So there we got it on. So now, I think you get that valve shut off. Nobody wants to get wet. So there, finally, this thing is under control, as according to their regulations. For us, it's the gas there, and that. So this well had this amount of pressure on this well, as we found out.
Did you weld that in after you had it in place to hold it? Did you weld straps around it or something to hold it?
Oh, no, his welding's good enough. He can weld pipe good enough that he welded that fitting, that 6-inch T on top of 6-inch pipe.
No, but I mean, just to keep your packer from pushing up out of there at all? They're just holding it on?
No, the packer is Johnson screen type packers,
Yeah.
and so they're 5.5 inches inside, and we had a riser, a 2-foot riser.
Right.
So the water was coming in and through the riser and then back into the 6-inch T.
Yeah, was it coming up, did you just keep the top head down on it?
Oh yeah, no, yes, no, we couldn't even physically, young helpers always think they're strong. Well, they ain't that strong, man. Yeah.
5-inch fittings, or like T's and all that, fit on 6-inch casing perfect, so it wouldn't make sense well.
Yeah.
Yeah, but you physically had to use the rake to push this down.
How many days did it take you to get to that point?
This is about 48 hours after our initial blow-in. So we were lucky, we had supplies on hand, and there was enough there. The 6-inch T happened to be sitting at a pipe supplier's in Fort Nelson. So,
And it blew like a jet engine for 2 days that first start. It blew like that.
Yeah.
That wasn't static on the speaker, that's how it sounded a mile away.
yes. So there was, well, I don't know where this one.
That's Hazel's.
Well, that's Hazel's, but anyway, as you can see, these things are, I mean, we never expected it, and these are, we look at people that work in that local area, and good thing there's seismograph work done in that, but they only drove 50 feet, so that's, can be kind of percentage-wise safer, But if there was some other auger type rig or came in there, encountered that gravels, boy, would they be in trouble. So, this is just another flowing well that we got a picture of. So basically now, I guess it's question and answer for either Rick or me. If there's- I'm flying in here and noticing the one thing I noticed, we all, as drilling people, we all look at geology, and, you know, for us, it's all mountain ranges, going into sedimentary plains and stuff like that. We probably get, and that's why we get some of these higher pressures for sure, because the feed is so, you know, from higher elevations. And that, and between the history of the country, glaciation and that, we get, especially on the west side of the Rockies, we get a lot nicer gravels, all clean, because of glaciation. These stream beds are all washed very well, and we get some very, very good flows in that. There was, Rick had a picture of that big artesian in Fort St. James, and myself, we drilled and knew about it because that was drilled in the 60s, and when I was cable field drilling, and we drilled a well closer to the lake, to Stewart Lake there. We knew what we were going to encounter. We knew what we wanted for surface casing. We put in, if I remember right, 140 feet of 8-inch surface casing. We drilled a 12¼ inch hole to start with, mud rotary style. Installed that casing in there. We cemented that all in, let it set for 48 hours. We drilled 6-inch through that after. So then, by now, well, we'll drill this with air. So, hey, we got an air rig. So away we go. We're getting close, and we're getting close to where we knew the production zone should be. And we welded on a piece of casing, and then that next 20 feet, away she went. But lucky enough to stop just below that 8-inch. But boy, was there water flying, I'll tell you. And rocks and water, but okay, well, let's get them drill rod out of the hole. So we got the drill rod back out, but we had flanges on there, so we were able to put a flange on there. Now this well up there, well, today I think they're running about 55 PSI on it. You want to slip a flange on at about +2 and have, well, the well flowed at 1,400 gallons a minute. It's a lot of fun, and boy, do you get wet. There was kind of a race to get back to the motel room later on that day. Who's going to have the shower first? Who's going to have cocktails?
Yeah.
But one thing about drilling, and I believe this is about all of us within the industry that do drilling, it's challenging. One of the few businesses, we start at the top and go to the bottom. We go in the hole all day. We never get to see what we're doing. Well, that's not the way business is supposed to be run, really. You know, so it is a challenge. But I've been at it for 50 years. You know what? I have no idea, no thought of quitting. I want the young fella to take over, yes. But Dad sits in the pickup and he's a consultant now. But I don't get paid for it either. But anyway, it's time for a new generation. We need a new generation to start within these industries. We're all getting older. We all think that retirement or getting holidays or something. I worked 50 years. I get 5 to 7 days a year off. That's all I can take. My wife allows it. Now that's very good. You know, because we've been married for 45 years. And I'm proud of her for that. But she knows what it's all about. And it's work, and it, you know, makes you what you are. But you got to enjoy your work. And to me, it's been a very, very good industry. And I'm kind of proud to be in it, really.
Yeah, we all should be proud to be in it because, as I often say, I can do without lunch for 2 or 3 days, but can't do without water.
Well, you sure haven't.
Well, no, I know. But no, we're in a real important industry, and sometimes we don't value ourselves, and we should, because we're a very important part of life, daily life. Everybody takes for granted. I mean, I've drilled wells for people that have come out from Vancouver into the outlying areas, and, you know, they don't realize that, you know, you turn on the tap in Burnaby or whatever, and they got flowing water, and some of these wells aren't producing as much as they should, and they run out of water, and you don't, you know, they're washing the car, gardening, and you have to be a little bit more conservation minded. The public is slowly realizing that, I think. It's gonna take a while, but again, going back to California, the crunch has come on, and you know, BC, we always say we always got lots of water, but it's, the problem is that all these aquifers, we've been depleted in the last, seriously depleted in the last 100 years, especially with California's, you know, growing programs, orchards and vegetables and everything. So they're sucking out a lot of water. And of course, the water that they're sucking out took hundreds of thousands of years to get down there. You know, and everybody says, well, you got the hydrogeological cycle. The problem is that water's not getting back down there as quick as we're sucking it out. So we're in a dilemma. And you're gonna see, and you've all heard the classic term, where there's gonna be more strife about water than anything else. And as one of my friends said to me the other day, we get along with the United States really well, right up until the time the Marine Corps band is at an airport there wanting our water. And they're wanting our water now. They're talking about a pipeline from Alaska going through Canada into California. So anyway, I think we all do a good job, and hopefully we brought some kind of information. I know there's well diggers out there that we weren't able to help too much. Possibly guys like Derek somewhere here can put together a you know, a talk on it. We don't talk about dug wells very much because there's not a lot. There is dug wells in BC, but there's not a lot of them anymore. And the reason is, in a lot of these areas, the water table is dropped. A lot of the wells I drilled in the Lower Mainland was to replace dug wells because they just went dry for however many reasons. There'd be construction above, changing the natural pathway of the flow of the water.
Even logging.
Even logging.
You know, the
Yeah.
watershed drops, tables within the watershed drops.
That's right.
Now they're not, it's not there anymore, not like in the 60s when I started, where everybody was using a backhoe or so to basically dig a well. Well, logging in within surrounding areas, and now that water is not being penetrated into your surface and in the spring, it's gone, and so it's not there anymore.
And you guys are lucky here that you're still able to do that, because, you know, I'm talking to some of the guys that, you know, you drill a well and you get saltwater intrusion, and then it's no good for anything. So you got to go back to the dug well, which makes perfect sense. You know, I mean, some of the places that we go in, they not only quit using it because of pesticides, fertilizers, ranches, barns above, because the elevations, you know, there's some new barn, cattle barn, or horse equestrian center might be built, and just for a lot of reasons. Not that it wasn't good to begin with. So we do a lot of well decommissioning for dug wells, and the regulations are there, 3 feet of bentonite chips. So generally for a 3-foot dug well, you guys would know about this, is that for every 1 foot, it's about 10 bags of chips. So usually 30 bags of chips to give you your minimum of 3 feet. But then what happens is, a lot of times, you know, you gotta ask them, well, what are you doing with this? You're probably gonna take off the top ring and dispose of it. But sometimes guys are building parking lots or something on top of this in a residential or development area. So you gotta tell them to put in clean crushed rock for structural integrity. because now you're responsible for what the end result is there, or you may be held responsible. So you gotta think one step ahead. What are you gonna do with it after? So I always recommend like 1/2 inch or 3/4 inch clean rock, because you can't compact rock that's dirty. So then that gives them a base so that if they do, pour concrete or asphalt, the chances of it as subsiding and causing a dimple are minimal. So it's not just throwing bentonite in the ground or in the well. So we can't really talk on dug wells that much because we know what they are, we've seen them, we worked with them, but you guys are probably more of the experts than we are.
You'll teach us.
Teach us, absolutely. So, yeah.
Just curious your thoughts on dealing with open loop geothermal, or pumping it out of one well and putting it back into another one.
Yeah.
Sometimes at the high static water level, they don't always want to accept all the water.
Yeah.
What are your thoughts of dealing with the flows on those?
Here's my thoughts. I don't really like open loop geothermal. There's a lot of successful ones, a lot of failures that happen in BC. The thing with it's one thing to drill a production well. It's a whole other animal to drill a relief well, not a relief well, but an injection well. And I'm not an expert on it, but I know in dealing with a lot of this is that sometimes if hypothetically you're producing 100 gallons of water a minute. Well, as it goes through the heat exchangers and everything, that's number one key, is to make sure that whatever it's going through, it's not contaminating that water to go back into that same aquifer where that water is coming from. That's number one. But sometimes you have to drill 2 wells that can take 50 gallons a minute. To drill one well that you think is going to take back 100 gallons a minute, sometimes it works, sometimes it doesn't. There's been a lot of failures because of that.
And also, you got to dump below the water levels, or else then you get between the chemicals of the water. Well, then you get a buildup within your injector well, and then it's going to fail too. At home, even we did one a couple of years ago. They were very lucky right in the city of Prince George. It's nice gravel bed. So they out in their parking lot, about 20 feet down, they dumped right in there, and never did drill another well for re-injection. But the Ministry of Environment said they could do it, so that's what they did.
I mean, if it's got some kind of a chance to recharge, it's good, but it's going to take a long time. So, but we find that the screens in the production wells on open loops, as compared to the screens in the injection well on an open loop system, the injection well screens plug up faster. They mineralize faster. They just cause more problems because of poor construction factors. And it's relatively new. I mean, GeoExchange is, and I've been in it for probably almost 20 years when it first started in BC, and got involved with the grouting and the geothermally enhanced grouting, and which is, it's another topic about the grouts for that, because I don't know if you guys want to listen to that, but that's another topic. If anybody wants to talk to me about those, because I've done a lot of that, and I know that the pitfalls, and I've had some of the manufacturers' reps years ago from the States come up on site with me and work with me for geothermally enhanced with sand, 200 pounds of sand. So I learned a lot about it right from the horse's mouth, and helped me out a lot. I was lucky that way. But there's little tricks to everything. You guys got all your own little tricks, and it's virtually impossible to write them all down because you will remember them when something comes up. Oh yeah, forgot about that, let's try this. My dad was great at that. Like, I'd sit down with him and he'd solve a problem the simplest way, and then you feel pretty humble because why didn't you think of that, you know? But that's what I was saying earlier, is that, you know, well drillers don't really talk to each other about what they do and that, but it's coming to the point that we're all gonna have to work together and ask questions and get it done, because Big Brother's gonna be watching us. And water, and every day there's an article in the paper about water. So, BC's really a long way, as you see in their Sustainability Act. They're dead serious about this, so. Because there's so many important industries there, winery, vineyards, where I live, there's blueberries, raspberries, you guys got the same stuff here in your own crops here, but, wow, when I was driving up I-5 through the San Joaquin Valley, there was miles, as far as I could see, of orchards. And you go through it through a few places, and there'd be trees. They were big trees, I don't know what they were, but they were all cut down. Far as the eye could see, and they had big wood chippers on there. So I don't know whether or not it was because of disease or that plant or that tree ran out its course. I know some orchard trees, they reach a certain level and they're not good anymore, or they just didn't get their quota for water. And we're talking millions and millions of dollars of loss. And of course, every time something like that happens, our tomatoes go up, our apples go up, or whatever we're getting from California. Because I think California provides 80% of the vegetables to, well, not North America, to Canada and the United States. So, any other questions? Come on, guys, please. I flew 4,000 miles.
I used to do a lot of,
My arms are sore.
here, I got a question for you.
Yep,
I used to do a lot of geothermal open loop systems,
yep.
and if they're done right and properly, there's no problems with them.
I agree.
And I've been doing them since 1979,
Wow.
since the first one. I was probably the first one in the Maritimes to ever do it. But the problem is, rule of thumb, you gotta know what you're doing.
Yeah.
And a lot of these people don't. These guys come in, I used to make a lot of money at it. Now I don't get a job anymore out of it because the price range comes in and they don't know what they're doing half the time. And they cut the prices and then they get into problems.
Yeah.
And you don't want to hear about that. You don't have that problem out west.
No, we're all pretty flush.
But they do work. Where I have a good aquifer and it takes the water. But there's a rule what you got to do on your discharge well, okay?
Yeah, well, you agree with me then. It's gotta be handled properly, constructed
Yeah.
properly. The thing is, like even open loop, closed loop, the prices are getting so bad. I know one job in Richmond right now, I can't believe what they're drilling it for and stuffing the loop in and grouting the hole.
It's crazy.
Oh, it's nuts. Like, well, I'll tell you, no, I can't tell you. But it's really hard for me to imagine that you can make a profit at it. Profit is not a dirty word.
No.
Everything we use self-destructs. That's the kind of equipment we work with. And we forget about that. Sooner or later, it's got to be replaced. And that's why, we're struggling with the new generation coming up to do your jobs. And there's a small amount of young fellows picking it up. I always knew that a helper was no good when he backed away from the rig when water started shooting out or got water on him. You're working on a water well. So, I don't know, it seems that there's like right now, John and I, there's about 10 years ago, there was about 12 well drillers in the lower mainland of BC. Now that would take from, let's say, up the coast right to Hope. To Hope. So there was at least 12 well drillers there. Today, there's 2?
I thought I heard 4.
Okay, maybe 2 or 4. A lot of those guys, their sons went on to something else. They just couldn't make enough money. They didn't have enough money to replace their rigs. They didn't value their services. And I know you guys probably all talk about the cost per foot. And, you know, and I hate to say this, but sometimes guys don't know what it costs them to drill per foot. And I used to work for a company that made drill steel for mines. And I remember going to a mine in Kennecott Copper, Utah Copper, just outside of Salt Lake City. Huge mine. You can see it from space. And these guys, when you went in to talk to them, they had it down to the penny. They knew what it was costing them. So to price out jobs, this wasn't my intention to talk about it, but the reason why I'm talking about it is because I'm concerned. I'm a well driller. I know what you guys went through. You know,
Well, I started in 40 years ago in our area, and there was 9 contractors.
yeah,
And in 40 years, there's only myself left.
well, that's kind of gives you an idea of
But,
what's up.
that's what'll happen. The next community will move in and cut the prices, and then you'll be in the same boat again, eh?
Yeah, well, I don't remember Imperial Oil saying, or Irving Oil saying, no problem,
Yeah.
pay in 30, 60, 90 days,
Yeah.
Rick. I don't remember him saying that.
10 cents a liter.
Yeah, oh, yeah, and we're gonna give you 10% a liter. I don't remember, or going into the liquor store and saying, Rick, no problem, take 2 bottles, pay in 60 days. I don't remember that.
You missed that.
Somehow, I guess, I wasn't in that club. Did you get a card or something for that? But these guys want their money, they want their drill steel, they want all their products, and they've all gone up dramatically. And some of us are still sitting at the same price.
Yeah,
You're
but
not
he
going
probably
up-
got more. He probably got more money for his well back then than he would now.
Yeah, that's a good point. Yeah, in
Yeah, your
relationship.
net
to-
profits are better,
Yeah.
very much better. In the 60s, they were very much better than they are today.
Oh, of course they were getting $20 a foot back then.
Yeah, you think
No,
it's
yeah.
do you think it's a coincidence when you go to the dentist that they're all fairly similar costs? Or when you go down to a service station and the service station may be off a couple of cents? You think that's a coincidence? No, we gotta stick together, and whether you be in Nova Scotia or British Columbia, I don't drill anymore. I just play around with this stuff. But it concerns me when I see guys, you gotta value your services, because it's water. Does that make any sense?
I've seen a bill,
Okay?
I've seen a bill back in 1954, a well being drilled in Smithscottle and Digby County. Drill rate was $10 a foot, a casing was $8.
Yeah,
And you can just imagine what they were getting for wages and what the price of gas was
yeah.
back in 1954.
I started in 1966. We were getting $10 a foot. I think our pipe was costing us about 2 something a foot. You know, gasoline was around 40 cents a gallon. Yeah, things have changed.
Yeah.
Oh yeah, and I got less hair too.
That doesn't seem to have,
Well, you start with a think of this. One of the nice pieces of machinery still today is a cable tool. Really, it'll make you more profits than any of these best of the air rotaries out on the market. Yeah, he doesn't drill much, but he doesn't cost very much to work either. You know, and if you want to apply the time to it, yeah, it'll
well,
pay.
John's got a drill rig that was 1150, 1050, 350?
Yeah,
Okay, 1150 CFM, 350 PSI, higher horsepower, higher pressure, more fuel.
more fuel.
You can
Yeah,
burn.
I like it.
What do you burn in a day? I bet you $1,500 worth of fuel a day.
Well, I don't know, 600 liters a day.
600 liters a
And,
day.
well, I had a Caterpillar engine on the last one. Caterpillar was a little better. It was only about 500. But, you know, Now, if you remember that picture we had earlier, that old truck guy restored, that's a 1947 Mercury flathead V8. You know, well, it really doesn't burn that much fuel, and that rig was, no, memory lapse. That's a 1947 Sullivan, which is kind of the predecessor to like a 1500 Failing or whatever like that. Some of the actions are all the same one. You know, and that old rig worked I know where it came out. It came out of Alberta and on the border, Saskatchewan. That, you know, them guys were drilling in them days probably for $5 a foot. You know, but the initial investment was awful darn low compared to today.
You know, another thing too is that just came to mind, and I'll quit here, but just finished working for an oil field drilling contractor out of Calgary, and it was because they had a similar name to mine, and they wanted to move into BC. I took an exception, ended up selling it, and then part of the deal was I worked for him for 3 years. So part of the thing is that a lot of sites I go to, because the oil companies were dealing with water, and they wanted to have a registered well driller in Alberta make out the Ministry of Environment well report log. So that's basically what I did. But what's interesting about that is oil field drillers to water well drillers, for example, is that in the old days, I mean, I used to work in oil patch in the 70s in Fort St. John. And the tool push was the tool pusher. He was the man on the job. He made all the decisions. Today it's not tool push anymore, it's rig manager. You guys are probably familiar with that. And now they're told what to do. They don't think for themselves anymore. They may have an opportunity to consult with the company man on the job, but we don't have a company man on the job. We are the guys making the decision. So yes, they got all the sophisticated equipment and everything, but we're better than them. Thank you, guys.
Thank you. We came all the way from the beautiful British Columbia to put on this presentation. Thank you very much for coming. It was very well. Thank you.
Thank you.
We're going to have a quick break again. Get up and stand up and stretch your legs. Then we're going to have Geroid come up and do the presentation. We may not have enough time for having a presentation on caustic pressure systems. I'm sorry, due to time lack. I know everybody wants to get out of here, but we will do on proper grouting procedures.
We'll make them stay.
You're insulting. But anyway, we'll give you about 15 minutes. All right, thank you. There's more refreshments up there. No liquor, but refreshments.
Little monk. So there's some speculation. They don't know if it was in China or in Europe, but I suspect it was more in China. So flowing artesian wells, so what's the problem? Why is everybody excited? Everybody says, I'm sure you've heard guys, customers say, oh yeah, I want a flowing well. Well, sometimes it's good, sometimes it isn't. This is a corroded well casing that was taken out of a flowing well. And this is kind of what happens in some occasions, because depending on the type of minerals and materials that these casings are made out of, you're going to get this corrosion, which really complicates your job of trying to control the well. So you can see here, just kind of an idea, this well is flowing and it's very little flow there, but look at all this flow coming around the outside of the casing. So, I don't know if you can see that fairly well, but you can see what happens from that well. Silt is coming up and it's going into this, well, I think it's causing a stream or adding to this stream with silt. And if it's fish bearing, and you guys got DFO just like we do, they don't take very kindly to that, and they wear guns. this is kind of an idea of what can happen. Probably you guys never seen that before, but this is how serious some of these flowing wells can take place, especially when the water's coming around the outside of the casing and causing really quick erosion. There's another one. So, when you say, you know, it can cause big problems, until you see these pictures, you can understand how things can get out of hand. And that's basically because, you know, the top overburdens are losing their water between the sediments. And then once that water is gone, your sediments shift and you're gonna get subsidence, and that's when everything starts to go awry. Hello, Mr. McRae.
How are you, Mr. Cronin?
Good. So like I say, I'm gonna breeze through some of this stuff, but you can see here that in this particular shot, there's 1, 2, 3, 4, 5 flowing wells. And Northern California right now, they would love to have that. Because as you all know, they just had a decree from the legislature that they want everybody in California to cut back 25% in water usage. So it's very serious. I just drove up through the San Joaquin Valley, and it's very serious problem. This one is kind of unique. The guy that helped me put this presentation together, he was a master at finding out some of these shots. Like you can see, this is in California, San Joaquin Valley, and this was the ground level in 1925. And just to accentuate that, this is the ground level in 1977. It dropped 9 meters. So that's a lot of water. And I mean, there's other things happening in California with the shifting grounds, with the faults there. So, and this is some of the signs you see. You know, less water, higher food costs. So all this produce coming from California, you're going to see it's already started to climb, but it's going to get higher because they got some serious water problems there. And I guess the point to this is, you know, with these flowing wells is not to waste water. This was a well I did, this was actually a whole section of wells I did in Okanagan region in central BC. And it got to the point where there was so much water there, the ducks started to use it. Big problems. Not expected, failure for pre-assessing your location, no precautionary measures taken. This was just a hole in the ground. We were building a resort just in this area here. All this water, this was just a hole in the ground that was flowing about 50 gallons a minute. It was flowing down into their foundation and causing havoc. This was the parking lot. So because there was no, there was actually a 6-inch, indentation in the ground. So we knew there had been a well there, and we suspect what happened is, and of course nobody will, own up to it, but we suspect that when they were excavating this area, they may have pulled that casing because it was an annoyance. And then, of course, once you pull a casing, you've got no control. So we had to put this PVC in to regain control. So when you're dealing with them, we're trying to, 6 goals we're trying to strive for is, the first major thing is to help preserve the artesian properties of the aquifers. And conserve the groundwater resources. Property damage, one of the big things and adverse impacts that flowing water will cause. and adjacent wells. Because we all know, maybe you guys deal with this too, is that in some areas in BC, and I know in Ontario, that, of course, if you get a flowing well, and you will affect other wells eventually. Improve industry flowing construction practices and achieve compliance with your provincial groundwater protection regulations. So, this is just kind of an overview of what you could be dealing with. So obviously you've got your upper and unconfined, your permeable material, confining layer, and then another more permeable material, and bedrock. So you've got your recharge area. You can see your water table, your piezometric, or in some cases they call potentiometric surfaces. So right there is where we're talking about for this aquifer. There's a lot of different, like this is classed as an artesian well, but it's not an artesian flowing well. So this is where you've got the problem. This top of this well casing is below your piezometric water level. That's why this is flowing. A little simplistic map, but it gives you the idea of how these things occur. So this is kind of a little bit of exaggeration, but because it's right beside the stream, but that stream may be however far away, it doesn't matter. So you're going to get erosion, and then of course we're talking about the fish habitat. I worked on controlling some flowing wells in Surrey, BC, where the ditch was classed as a fish-bearing stream. So we were using cement, and they made it perfectly clear that we couldn't get anything into the ditch. It was kind of like on the side of a ditch where they had widened the road, and originally it was in the field, but it ended up on the side of the ditch. So we had to make a diverter out into the farmer's field just to make sure, because we were being watched pretty close. So this kind of gives you an example. I'm not going to get into all this, obviously, it's pretty complicated, but this is in Florida. Brunswick, I don't know where that is, Ronnie. Is that Brunswick, Florida? Yeah, anyways, this is right on the Atlantic Ocean somewhere. So obviously on the east side. But this kind of gives you an idea of how complex aquifers can be. And there you've got a flowing well there. And I believe this is, this was an actual well that this company here made this slide up. But it just goes to show you, especially, I guess, near oceans, because I know you guys, if you drill too deep, you can get into saltwater intrusion. We have the same problems in BC also in some places. But it can get pretty complex. And of course in Canada, we've got all different geological formations. And that's why Canadian drillers are prized around the world. Because if you can drill in Canada with all the different formations, you can drill anywhere in the world. And it's important to know that. So you guys are well recognized around the world. And of course we know this, every hole is unique. So even the most experienced drillers, you know, you should, if you got a problem, and I know drillers are famous for this, me being one of them, is that you don't really want to talk to other drillers because then it kind of says you don't know what you're doing. But, right, I mean, these days are changing. You gotta, especially with the regulations that are coming in now, and we're all one group. And it's getting to the point where we've got to help each other. I know I phoned John on many occasions and asked his advice. So, I'm not familiar with your water well databases here in Nova Scotia. I'm sure you have them. With, so when you're going into, you know, known artesian areas, you should do your due diligence. Sometimes, do any of you work with hydrogeologists on occasion? There's any in the room here. So, you know, sometimes, I guess what I mean by that is, if it gets too hairy, I know sometimes for us, we'll hire an engineer. So, you know, we'll confer on the problem, and then he's the guy that puts his stamp on it. So, you're talking liability issues. So obviously they're usually in unconsolidated formations. And of course, shallow wells are always harder to control than deeper wells. So, I mean, I've drilled some bedrock wells. I think I had one of the guys here I was talking about in the parking lot that they drilled a bedrock well, and it wasn't immediate evident that it was flowing. You may come back the next morning and it's flowing. So they can be a little bit trickier with the unconsolidated formations. You're going to know pretty well right away. So it's just not water wells we're talking about here. You know, you're all types of borehole drilling. Geo-exchange, big problem. Geotechnical and environmental. Elevator shafts. I've had problems with elevator shafts, and they're shallow water shafts, but in the Okanagan I had a really bad one. And cone penetration test holes, which just goes up into your geotechnical and environmental. And in BC, I'm not quite sure where you guys are at here, but we've just introduced new programs for geo-exchange drillers that they have to get their license now, and I think it's 4,800 hours before they can apply with the Ministry of Environment to write their exam. And the reason is because of water. I mean, they're drilling the same boreholes as a well driller is, sometimes even going deeper to get the thermal conductivity. So once you start drilling in some of these areas with a series of boreholes, you know, 15, 20 feet apart, make the place look like Swiss cheese, there's just some areas that geo-exchange is not, you know, feasible. This is one of Dave Walsh, one of our old drillers. He's no longer with us. So who's responsible? In BC, the landowner is responsible for costs to control flowing wells. And drillers need to be careful to follow the best practice procedures and construction methods. And what I mean by that is, if something goes wrong, the ministry, and if there's an investigation, and now you get lawyers involved, they're going to want to diligently go through all your procedures, your documents, to make sure that you've followed the best practices, best construction practices, and if you try to cut corners, specifically in known artesian areas. Contracts. I used to do wells by a handshake. I'm still sure a lot of you do that too. And today it's the day of contracts. And you really gotta be careful with that and you gotta really spell out in your contracts who's responsible for what. And I got a pretty comprehensive contract that's taken years to develop for reasons. And he can be a good buddy, but when something goes wrong. So the other thing is, I don't know, we in BC, because we've got a lot of problems with flowing wells, the provincial government came up with a brochure specifically on flowing wells. We never brought any of them. But what happens is the reason why that's good is because if you go on a site, meet a customer, if you're in a known artesian area, you'll be able to say to them, well, we gotta construct a well like this. It's gonna cost a little bit extra more money with the, let's say, the surface casing that you gotta install and the cementing, and which we'll get into here in a minute. But it's not just us saying that. Here's what the provincial regulations are. So again, I don't know where you guys are with that, but what it is it's not just you saying this to the customer. You've got government regulation backup. And I'm one for not government regulations, but in some cases, they will help you. In some cases. So I'm going to kind of quickly go over this because this is the new Water Sustainability Act that, because of all these problems we're having, this has taken years to get to this point. This act comes into play, it's already been passed, but it comes into play in January of 2016. So, again, I'll kind of skip through this now. Ron Nelson helped me with this. He kind of skipped some of this stuff out because these are actual words in the legislation. But a well is under control. This is their definitions now. Is when the artesian flow is clear of sediment, entirely conveyed through the well's production casing, and not around the outside of the casing. Because I've been on jobs, and maybe some of you guys have, where you've had the water come out of the casing, around the casing, and 20 feet away. Because you've poked the hole and broke the Pandora's box. So maybe mechanically stop for an indefinite period of time to prevent leakage on the surface of the ground or another aquifer. Because you may have two aquifers and they may not be the same qualities. So you don't want to have that commingling between the two aquifers. That's why we'll get into that in the grouting part. It does not pose a threat. So that gets back to controlled. Definition of control in their mind. Or, if it can't be controlled, which does happen, you got to kill the well. You got to decommission it. That's self-explanatory. Or leakage into another aquifer. So they've said they're holding, licensed water well driller. You got to do something with this well. In fact, I think in Washington State, if you hit an artesian well, I don't think you can take the rig off until that well is controlled. Or if it does start to cause erosion, the rig starts to sink, or it threatens life or property, you can pull it off. But they're pretty serious about that too. So if another person encounters flowing wells, flowing artesian conditions, you got to notify the well owner, which is obvious, but they're writing it down. So I'm not quite sure though if there's a well owner and or a landowner. I guess that does happen on occasions, but in the end, it's the landowner that is the ultimate responsible party. was telling you that you gotta comply. And the comptroller in the Ministry of Environment of the water well section, this is pretty onerous, but there's an end to this. So it's, again, it's, now, the definition of an engineer and BC Ministries definition is that it may not be exactly a professional engineer, a PEng. It may be an engineer that's designated by the Ministry of Environment, which may be a drinking water officer or a hydrogeologist. So, definitions of engineers sometimes work to their advantage. So, well report. So, what the BC government is trying to do now is they've naturally got a water well database, but they're trying to target a specific areas in BC where you have known artesian areas. So that, once this is all recorded, that you have a place to go and get as much information as you can. It's not always possible in that different remote places that wells are being drilled in British Columbia and possibly here too. So you got to document all this. And you got to submit these reports and documentation to the ministry. So you got to retain it and you got to produce it if asked. Submit a copy to the well owner and the comptroller. And now that he's got those reports, that he's now committed that he has to publish these reports. However he does that, I'm not quite sure yet. I guess people got to go into the databases. So this is really new. This is the new big one. So if you don't follow these guidelines, you're committing an offense in their words. And a person is liable on conviction to $200,000 or 6 months. And better yet, if you continue to do it, it's $200,000 a day. Now, obviously, that's pretty extreme. Chances of that really happening are, they're trying to make a point here of how serious this problem has become. So you gotta be licensed to do it. We'd love to have these wells in California now. Yeah, contract clauses, I can't stress enough on that because you really gotta cover your butt on this, guys. Fact to the point where the contractors are avoiding jobs in areas where they know they can run into a problem. Michigan is a big contributor to a lot of states. The National Groundwater Association has taken a lot of their positions from Michigan. And of course, the insurance companies picked up on that. And you can, over and above your liability insurance, you specifically can get policies for artesian breakout. So, panic may lead to hastily made decisions. I can't stress that enough. So never use native cuttings for control. Drop native cuttings down the hole. That doesn't work. Never dump stones or gravel. We've all seen that. That doesn't work. Because you're going to have to re-drill it out anyways. Avoid ready-mix concrete or bentonite chips for control. A bridge above the source depth. So what that is I've seen guys on a geothermal hole. They got a ready-mix truck in, and they're trying to pour concrete, not cement, concrete, down this hole. set the trough over it, and some of it's getting down. But what happens is that when it's flowing, when the water's coming up, it takes away the cement, the Portland cement away from, that washes it away from your aggregates. And then what you've got is just basically going back to the gravel. So you never give that concrete time to set up, because it'll just separate. And I've seen that. And chips, of course, don't have the weight. Depending on, sometimes you can get away with it, sometimes you can't. And again, 6 actions to avoid inadequate penetration depth of outer casing, which you want to get that into the confining layer. And guys loving jamming stuff down the casing. And we've all heard the story, I jammed this big log down there and I got her snugged in. Well, okay, I guess it worked. So, a little bit of control physics. We're not going to go into a big thing here. Of course, we all know, this is all US, because any grout information is always in US. Of course, water weighing 8.3 pounds per US gallon, and you're dealing with 0.43 PSI per foot. So it depends on, when you're using a cement grout, this is specifically for pumping down a kill a flowing well. If you were using 13-pound grout per gallon, you can achieve 0.70 PSI per foot. So these are just a little bit of an example here. So this is typically, this is an oil field blend. So 94 pounds of Portland cement. The reason why they use 94 pounds is that they have 94-pound bags of cement in the US. Here we have 40 kg or 88-pound bags. And again, these can be massaged, but 5.2 US gallons is generally the amount of water that you're adding in with that amount of Portland cement. And that'll give you approximately 15 pounds per gallon, which is a lot. So, yeah, so 100 feet of column of water, you got 43 PSI. 100 column of grout, when you do the math, is 70 PSI. So you can gain control of that well with that grout. And remember, we don't necessarily have to overcome the flow. It's the column weight to overcome the head pressure. So this is just a little slide that Ron had added in, just to show that. So you've overcome the head pressure with the column weight of grout to that depth. Now, generally, I would have gone right to the bottom. But pumping that grout into an aquifer, you got to be careful with that too. So I'll touch on that. You don't want to be contaminating the aquifer as least amount as possible. So let's say you got a 150-foot well, your head pressure is 40 feet. So that means you'd have to have 40 feet of pipe in the air to stop the flow. So you've got 82 PSI at source depth, but you still only got 150 feet of casing in the hole. That's all you got to work with. So, so then we're backing off here on poundage of grout per gallon. So you can get 100 PSI. So going back to that 82 PSI, with the grout column, you're getting 100 PSI. So since the 100 exceeds the 82, obviously control is possible. The bad part about shallow wells, they're the most difficult and they're the ones that cause the most problem. Similar situation, 50 feet, but you'd have to add 40 feet on, but you only got the 50 feet of casing, is 35 PSI. So you don't have the sufficient grout column, heavier grout or other situations. So you can see here that You just don't have enough height and weight. So methods and equipment. So when you're dealing with any of this, you know, I had a custom grout machine made, had a 50 horsepower John Deere diesel on it, 2 stainless, 80-gallon stainless steel tanks, a 250-gallon water tank above. And it was built for openness, to get at everything easy while you're pumping, like breaking valves on your pumps. What's the name for those valves? The escapes me now. Hammer unions. So in some cases you gotta have the power to do this. Here, sometimes you're on wells that we deal with that we just can't mix the bags fast enough. Because you don't wanna have interruptions. So, continuous placement is the most optimum way. So what we tell these guys, the ready mix guys, and I've done this a number of times, is that they freak out because you're asking for Portland cement. And of course, Portland cement in concrete, there's not a lot used, but you're telling them, well, I want 7.5 cubic meters of this Portland cement, and they get really scared because they come out to the site and I tell them to bring retardants, and it's not a continuous pour. I mean, all we're doing here is we're running his trough into our mixing tank or agitator tank, and invariably you'll tell them to clean the drum, but they won't because there's aggregate in there. They'll never clean out all those little rocks. So you gotta put a screen on top of the mixing tank and then the trough, and then catch those rocks, because those pumps that we're using are slurry pumps, and they got springs and steel balls, so anything that gets in there will stop that valve, and I can tell on the pressure gauge where that's coming from, what side of the pump is coming from. But of course you learn all this when you've got cement setting up in your tank, and there's everybody, and I'm yelling, and then it's nothing personal, just do what I'm tell you to do. So the adequate trimming diameter, so I'm saying 1 inch, but I've done that, that's really the minimum. Every manufacturer, grout manufacturer will tell you minimum of 1.25 inches, preferably 1.5 inches. Sometimes that's not possible. I've used up to 2 inch, but when you use 1 inch, you're really losing your window of, you better know what you're doing, because that's, the smaller the diameter of trimming line, you're going to increase your pressures and restrict your flows. You're going to have friction losses. So, you know, prior to any of this, killing a well, you've got to remove everything from the well. Prepare to have all your fittings there with you. You can't stop in midstream when you got all this money sitting around and guys standing and ready mix trucks. Everything, sometimes it'll take me 3 days to prepare for a 2-hour job. But everything has to be done and prepared right. Preparation is everything. And of course, homogeneous mixes is important. That's why when I get these guys to do this, I'll go to the ready mix plant and I'll get them to mix it the way I want, and we'll use super plasticizers to help the flowability, and it keeps things cleaner. Like when you pump that cement in with in your tank, it helps keep your paddles clean, your tanks clean. It's just easier to work with. So you have to have the proper cement admixtures. And with any grout manufacturer, they'll tell you, you know, you got to pump. It doesn't necessarily pertain sometimes to cementing, but generally you want to have the consistency coming out either the middle of your casing or the outside of your casing, the same consistency that's in your mixing tank. Because as we all know, you're gonna get dilution. It's gonna start to look really good, but it's not really good. It's diluted with water. And it could be a fair column, you know, you'll see gray and the odd, maybe the odd piece of cement, but you gotta keep, until you get the same, keep pumping until you get the same consistency. Be prepared, I keep saying, stressing on this, because that's huge. And again, you know, this is the type of equipment sometimes you gotta bring in to work in these areas. You can't bring a wheel vehicle in there, because of so much saturation. And this is Grow Properties. Ron has put some of these bentonite particles in. So it's standard procedure to have sealing qualities with your low permeabilities of 1 times 10 to the minus 7. So that's, don't want to get into all that, but that's on mostly all your bentonite grouts, your 20% or your 30% bentonite grouts, you will see it says around 10 to the minus 7 centimeters per second movement, which is really low. There's lower ones, but an ability to bond to the casing or the borehole wall. High specific gravity, which we talked about, which includes the weight. Inert or non-reactive with formation. Well, cement, generally you won't have a problem with that. The oil field uses different cements for different reasons. Easily mixed. Consistency and viscosity allow quick placing, and you can do the 1 inch. Self-leveling, in other words, it's got to flow into the areas once it's down into the zones where you're wanting to target. So minimal penetration into permeable zones. So what that means is that in some cases you're trying to pump into the formation, but you may not want to contaminate that formation. So I mean, there's been some wells where I've been on, I could pump all day and not achieve nothing. Sometimes you just have to back off, sometimes leave it and let it set up and do it in increments. Only if you've got the water stopped, because generally if you leave it overnight, that thing will start to flow again. And then of course if you got trimming lines down there that are at the bottom, they're filled with cement, you got to be careful with that. But you try to strive for that, but sometimes that's not always possible. So again, easily cleaned, reasonable cost. I don't worry about that so much. So again, cements are recommended for flowing wells. Bentonite prone to piping failure. So what that means is, if you start to pump down bentonite grout slurry, you may stop it for a while. In fact, it might work permanently. But what's happened in the past, especially I know in geothermal holes, is that they normally grout their holes with bentonite slurry, come the next morning and they got water coming up at surface. So they've somewhat stopped it, but they haven't stopped it. So then if they call me, I've got a chance here because now I have a pathway of water coming up in that grout column, in the hole. So then I can jet down with water with the trimming line. This is where your well logs, even on geothermal holes, which a lot of guys don't do, is have a proper well log so you know you have an idea where this water is coming from. So then you can drop your trimming line down to that or just a little below it, that zone, and then pump your cement down. And when you pump your cement down, that grout will not have totally hydrated, so you can push it out and replace it with cement and stop the water. Does that make sense? Yeah, so Yeah, once that water has broke through and started to pipe, that bentonite is usually hydrated to its maximum and it won't swell anymore. Usually. So, some mixes include a small amount of bentonite. I mentioned that about the 3 to 5% bentonite in cement. And we use friction reducers, accelerants. Sometimes we'll, on one job we did just recently, which was a case history here, we added, once the mixer was dumping it into our mixing tank, I think the total amount we added, about 50 pounds of calcium chloride. And again, you gotta be careful with that because that's an accelerator to speed up the setting of that cement. So you gotta be careful with that because you can really screw yourself up that. So cement setting affected by temperature, pressure, and water quality. Yeah, you gotta, with any of these droughts, you know, I know guys are pumping water out of the ditch and stuff like that and out of the lake. Generally, that's okay. But good clean water is always a good idea for any kind of drought. I'm not going to spend time on this too much. This is methods that guys have done with flowing wells. You can see this is just bad. It's got a void around there, water running through a drain into wherever. That is a no-no. Some guys get away with it, some guys don't. Same type of thing, but there's no gap. In other words, these types of setups, with the way, again, barometric pressures and that work, this well, it could be flowing, and you could turn that into a suction well. So it could without back pressure valves, check valves, you could have it sucking water from a source that you don't want it to come from this drain pipe and going back into your well. So cross-contamination, cross-connections, not really a good idea. So this is not always possible. This is a good way to do it, but it's not always possible because you've got to have that air gap in there so that there will be no chance of any suction back into the well. I know it sounds like crazy when you're talking about flowing well and then suction back into it, but it can happen. But this air gap is a standard way. But in cold weather, you may not work very well for obvious reasons. So, referring back to Michigan, again, I won't. Again, you're talking seals or packers. So yeah, this packer could be run down. As you can see, the red and the black wires, which is your submersible pump wires. So you can seal off that top. The big thing with that is, are you going to cause another problem by that? Maybe not, because if you block it off, is water going to try to come back from around the outside of the casing? So, you know, just an example, a 10 psi pressure acting on a 6-inch well seal exerts an upward force of 240 pounds. So you can set it into place by pushing it down, but if it's not totally sealed and pressured up, you could pop it out. Yeah.
This packer is shown there is, I've used it quite a bit and it works very, very well. I mean, you do have to have your surface seal and all that stuff in place, but a nice thing about it, the packer's there, your pitless is just below it, and so you put it in there, and then that rod on top there, you just tighten that rod up, and it expands the packer out against the 6-inch casing, I'll say. And so now, and it holds that flow. The one thing to consider is to put a bar somehow, or a stopper of some type, across that stainless steel rod, because I've had them, sometimes they'll sit there and, oh, you got her, oh, this is good. Well, next day, oops, it's up an inch,
Yeah.
you know? So if you put something across there, but it does stop the flow, it does work very, very well.
I think I can get through this, you just give me a few minutes, and I know it's getting close to,
The whip's not out yet.
chlorination, sometimes it's needed, but it's a big process. You gotta you gotta stop the water. Sometimes regulations make you do it. Sealed. This goes back to corroded casings. Why it's important to get the grout all the way down to the bottom pump it till refusal, because if the corroded casing is in that, with these zones here, you want to get the grout going out through the corroded casing spacings, also out into the annulus. I'll just zip through this, guys. Casing removal, I mean, that's a contentious issue, because I don't believe in casing removal. Some jurisdictions say you have to, but you're gonna lose control. You have to really an elaborate process to kill that well if you're gonna be pulling the casing at the same time. My personal opinion is if you're gonna do that, perforate the casing. Cut it, perforate it. Or leave it alone. Yeah. I mean, if somebody wants you to do it, so all else fails, I think we were talking about dynamite this morning. I'll just zip through this. Okay, so this is important. I really need to talk about this. So, you know, grout stories like drilling fluid. Some guys try to use drilling fluid, mud drilling fluid, to use as a, putting it back into the hole. Well, generally mud rotary drilling, it's only got 4 to 6% bentonite solids, and it's a poor seal. For example, like you're putting a 50-pound bag of escape me, well, 50-pound bag, you're putting it into 200 or 300 gallons of water for a drilling fluid. Whereas a grout, a bentonite grout, you're putting in normally on 20%, 24 gallons. So there's a huge difference in the bentonite. Bentonite is not bentonite. Mark Duckworth, I'm sure, will expound on that. But two different things, so you got to be careful. So don't use drilling fluid for a grout. Another thing too is, I don't know if you guys get into installing piezometers or monitoring wells. It's important to have, if you're doing it in a service station, for example, you got oil coatings. You gotta make sure it's clean, because otherwise you're not gonna get a proper seal. So, cementatious grouts are widely accepted in certain borehole applications, especially in oil fields. And many publications suggest that grout mixes work well for specific applications. So what I mean by this is that you get sometimes professionals that will tell you, well, I want this grout mix, but they're reading it out of a book. And I know what's going on, and you try to tell them that there's better ways to do it. So cement-based grout mixtures are susceptible to shrinkage and cracking, resulting in that microannulus I was talking about. And bentonite as an additive is generally perceived to have the following effects: plasticity and lowering hydraulic conductivity. That's that 3 to 5% mix that, I don't know if you guys are aware of that, but that's famous where we are. Increased cement resilience to cracking. Reduces compressive strength and resistance to chemical attack. There's some really smart guys that have done tests on this and say that these tests indicate that such advice is in error. And the reasons are that bentonite sucks up the free water from the cement. On deeper hole applications, the problem intensifies because the hydrostatic pressure on the cement squeezes the water out and bleeds. All cement bleeds. The higher pressure, the more it's gonna bleed. In fact, the bentonite cannot compensate for shrinkage in those amounts. And the problem is, I'm saying this, but I have some cement mixes, some grout mixes that are 88 pounds of cement and 50 pounds of bentonite. So I'm going against myself. Depends on what you're trying to do. So the sodium and bentonite mixed in with the cement is replaced by the calcium due to ion exchange. I mean, calcium bentonite has no appreciative expansive quality, especially in seawater. Bentonite itself does, it's hard. There's adipolgite grouts that are used in certain instances, but calcium will always win over sodium. And testing to indicate the addition of this 3 to 5% has little or no effect on cement shrinkage. So ASTM, you familiar with that outfit, states that bentonite may in fact increase shrinkage as it ties up the free water that would normally be incorporated into the cement. So those are really important statements that guys don't normally hear. And the heat of hydration, again, I talked about distorting stuff. This is what happens when you get a bad well in a house. No, I'm sorry. This is a house that somebody, this is a piece of art in Sydney, Australia, that they overlapped this water and pretty good effect. So in other words, erecting over a building with a plugged abandoned flowing well is risky, not advised. A plugged well, abandoned well, yes, but a flowing well, be careful, they're fragile. They're very fragile, and to fix that problem, once you built something over there. So here's some good resources. There's long handles here for the websites, but basically you Google flowing artesian wells, BC and Michigan is a excellent guideline. They've been doing it for a long time, and National Groundwater Association has used some of their, incorporated some of their regulations. So I'm just going to breeze through this, and then we'll do John's talk in the afternoon. Largest flowing well in Canada. This was done in 4,200 gallons a minute. Big problem. Big problem. So this was an article done by Johnson Screens. One of the things was that, just to show you some of the complexities that you have to go through sometimes, is starting off with, larger casing sizes, 20-inch, 16-inch, 12-inch, and to whatever, telescoping down, and subsequent casing sealing. So it can get pretty complicated. This is a well in Langley, BC, and historically was the first water source in the area. You can see the round circle there. You can see the building to the right of that red circle. That's a church, I think. And whoops, that's what it looked like before. That was 1911. That well is still flowing today. And the problem, so it wastes over 1 million gallons a year at 2 gallons a minute. And it's been doing it for 100 years. So because of those flowing wells, and the Ministry of Environment has identified like 600 wells in the Langley, Surrey area. These are old 2-inch jetted wells in that are flowing. They've identified 600, so if they've identified 600, you can imagine how many are out there that are really out there. and wasting water. And then they wonder why the aquifers are depleting. In this particular aquifer, the Hopkinton Aquifer in Langley, from 1962 to 2002, you know, it's dropped like 60 or 70 feet, 20-some meters. So, and then guys are running out of water, and they're having to get their wells, either new wells drilled. And what's happened with this one is it was designated a National Historic Heritage Site. So nobody could touch it even if they wanted to now. Oh, yeah, and this is important. So what happened is, there's a couple of wells there that have been flowing for so long that they've created their own streams, which has now had fish in them, which now the DFO will not allow those wells to be closed off because they're a designated fish stream from a well. So that's what happened, or that's what can happen. Coldstream, wow, this is a heavy case. I'm not gonna go through all of it because I don't have the time, I know. This well was drilled in 1965, 200 feet, 1965, so that's 50 years. Started at 500 gallons a minute, 30 to PSI, 30 to 50 PSI. Huge problems, still to this day. I think there's 3 or 4 relief wells. Millions of dollars that they've spent on this thing over the years, and it's still not solved. So